Hello, this has been McGahee with McGahee Mathematics. Today's video we're going to look at difference of squares, how to factor a difference of two squares. So let's look at the general formula on how to factor. We have a squared minus b squared. So that's going to equal a plus b times a minus b. Okay, so if you're not sure that this equation's true, just do the FOIL method, with a plus b, a minus b. And, do the first, outside, inside, and last. You see you'll get it. A times a is a squared. And then minus a times b is ab. Plus b times a is, we'll just say ba. And then b times negative b is minus b squared. And you'll notice here that the minus ab and ba is the same thing as ab, because multiplication is commutative. And so these are like terms. And so negative ab plus ab minus 1 plus 1, 0, right? Because they cancel out. And so we have a squared minus b squared. So we see that this equation is true. Okay, so all you need to do is think of, you have the perfect squares. You have a squared, b squared. Think of like the square root of a squared. It's a. Square root of b squared is b. And so if one factor, you add them together. And then the other factor, you subtract them. And then multiply to factor. So let's start off with an example. Let's say we have x squared minus 16. So we know that, x squared is x times x. And we know that 16 is equal to 4 squared, right? Because it's perfect square, so that's 4 times 4. So we already know our factors, right? We already know our value for the a term, that's going to be x. And then for b, we're going to have 4. So this will equal x plus 4 times x minus 4. And that's our answer for x squared minus 16. X plus 4, x minus 4. Okay. So let's look at another example where we have use different letters this time. T squared minus 49. So we know that t squared is t times t, and then 49 is a perfect square. That's 7 squared, or 7 times 7. So we have already identified what the a and b terms are, right? We have t, and then we have 7. So this is going to equal t plus 7 times t minus 7. There's our answer for t squared minus 49. T plus 7, t minus 7. Okay. Now let's take a look at a different one. You might not think it's the difference of two squares at first, but we have to do a little algebra and we'll find out that it can be used. So 3a squared minus 27. So you're looking at this, it's a difference with two terms. We see the a squared as perfect square, but the problem here is with 3 and minus 27. So we know those are not perfect squares. But we do know that there is a greatest common factor with 3 and minus 27. And so that would be 3, right? So we can bring out a 3. And then we see that this term here is going to be what? A squared. And then minus 3 times 9 is 27. So we have 3 outside the greatest common factor times a squared minus 9. So looking at this again, a squared minus 9, we do see that these are a difference of two squares, right? Because we know that a squared is a times a, and 9 is 3 squared, right? 3 times 3. So we already identified the a and b terms, which is the little a, and b is 3. So our final answer is going to be 3 times a plus 3 times a minus 3. So that would be our answer. For 3a squared minus 27, we rewrite as 3 times a plus 3 times a minus 3. Okay. So I'm going to clear and create a new board here. When we look at one more problem. So this problem we have m to the fourth minus 1. So notice that we don't have square for our variables m to the fourth. But m to the fourth is a perfect square, right? M to the fourth equals what? M squared times m squared, right? And we know that 1 is equal to 1 squared, right? That's just 1 times 1. It's 1. So we know in our difference of two squares formula, we have our a and our b, right? So we have m squared plus 1 times m squared minus 1. So the question here is are we finished? Well, we look at m squared plus 1. A sum of two squares. I don't think I mentioned this, but this cannot be factored. And so when you have something that cannot be factored, like any kind of polynomial, is considered a prime polynomial. It's just like a prime number divisible by 1 itself. So the only factors for m squared plus 1 are just 1 and m squared plus 1 itself. Now we look at m squared minus 1, and we do see a difference of two squares, right? Because we know that our m squared is m times m, and we know 1 is 1 squared, or 1 times 1, just like what we did earlier here. So we can definitely factor m squared minus 1. That's a difference of two squares. So just rewriting this, we'll have m squared plus 1. So we keep this the same. And of course we'll need an extra one, right? Because of m squared minus 1, we have our a and our b. So a is m, and then b is 1. So m plus 1 times m minus 1. And this will be our final answer for m squared, m to the fourth minus 1, and that's equal to m squared plus 1, m plus 1, m minus 1. Okay, so I just wanted to give you some different types of problems, how to go about doing difference of two squares and factoring those kinds of binomials. This has been McGahee with McGahee Mathematics. Do stay tuned for we'll talk about perfect square trinomials, how to factor those, and we'll try to go over in future the sum and difference of cubes. So stay tuned for those videos.